Now let's turn our attention to example number 2. In this question, I want to take a look at all of the different parts, or actually have you take a look at all the different parts, and see if you can find the value of each of these individual limits. So notice here that we're going to have limits where x is approaching negative or positive infinity, and our goal is really going to be to identify then if there are any horizontal asymptotes on the graphs of these corresponding functions. Like we had said at the end of the last video, whenever we find that the limit as we go towards negative or positive infinity equals a specific number, we know that equaling that number is the equation for a horizontal asymptote. So I'll ask you right now to go ahead and try to pause the video here and see if you can work through each of these 5 questions that are here. Now, some of these, again, may have a horizontal asymptote or may not. That is, you may come up with an answer for the limit that's just single number, or maybe you won't. And if you get stuck on any of these, don't worry. They're designed to be at a variety of different difficulty levels. And once you unpause the video, you'll be able to see me work through each of the solutions. All right, so hopefully you took some time there to actually go ahead and practice by trying each of these questions. Let's take a look at each of them and see kind of the way that we can approach them. Now, this first one here is actually very similar to the previous example that we had, where we were dealing with 1 over x. Now, I could think about the graph of this function 1 over x squared, but I might also note again that if my denominator, then that value for x down there, is becoming extremely large but negative, and then I square that value, I'm still going to have 1 over something that is ridiculously large. And so I can easily say this here approaches 0. So that means that on the graph, we would have a horizontal asymptote of y equals 0. And you could actually see this because if you were to sketch out a picture of this graph or use your calculator to gain a picture, you actually see that we end up with a graph that looks like this, and y equals 0 is a nice horizontal asymptote that occurs right here. Okay? So let's take a look at the next one, the sine function. Well, I'm going to go ahead and quickly draw out a picture of what my sine function looks like. Remember, this is a graph to know, so you should have an idea of what this picture is. Now, we know that our sine function just continues to kind of oscillate and go up and down just forever out in both directions. So this is kind of a strange question. What does the sine graph narrow in on? What does it get closer and closer and closer to as x goes towards infinity? Well, this is kind of a strange question because compared to what we did up here in part A, as I approach infinity here, I can see that this graph is kind of merging in towards this red line, right? It's slowly becoming closer and closer. But is there any y value that this sine function is going to continually get closer and closer and closer to if its graph continues to do this? Is it going to get closer to anything? Well, if it just continues to repeat this wave-like pattern, it's never kind of merging in towards any particular value. And so what we would say is, well, this limit here appears to just not exist. There is no value that the graph merges towards. So if this limit does not exist, then that means that on the graph, we would say, are there any horizontal asymptotes? No, there are no horizontal asymptotes here. And that, of course, is completely consistent with our understanding of this function. Now take a look here at part C, e to the power of x. Now, I, of course, can think about this geometrically as well if I know the graph of e to the x. And this is, again, another one of our graphs to know, and so it's very important that we do know this because it'll help us with questions like this very often. I can see here that I'm going to be jumping on the graph of e to the x and walking towards negative infinity. If I do that, I'm following the graph in this direction, and of course, what am I narrowing in on? Well, I'm narrowing in on the value of 0. That's the value that we get closer and closer and closer to. So again, we're going to have a horizontal asymptote here of y equals 0. Let's take a look at part D. Now this one's kind of strange because we're not starting with x approaching any specific positive or negative infinite value. It's approaching actually 2, but from the right. Now let's go ahead and think about what this is actually going to mean. Notice if this value of x is going to be approaching the value of 2, then my denominator here is technically going to be approaching something like 0. But notice that if x is going to be something that's always slightly larger than 2, then something a little bit larger than 2 minus 2, something a little bit larger than 2 minus 2 should be something a little bit bigger than 0, like 2.1 minus 2. It's almost 0, but it's a little bit bigger. So notice here I'm going to have something like 1 divided by something that's positive and approaching 0. We talked a lot in the previous section about what happens when I have something like a number divided by something approaching 0. What that really means is that the inside of these parentheses is actually going to be approaching a positive, infinitely large value. So notice what I'm going to do here. I'm going to try to reformulate the way that this question is being posed to help illustrate this conclusion that so far we've reached, that the inside of the set of parentheses is approaching infinite. So what I'm going to do is I'm going to redefine the entire inside to just be the number t. Okay, so there's some value of t that this whole inside crunches into, right? Imagine if I plug in a 1, the inside turns into a number. Call that number t. If x is something different, the inside turns into another number, call it t. And if x is approaching 2 from the right, then we've actually seen that this entire inside is actually approaching infinite. And so now we can think about this question. Really, I have an arctangent function whose input is approaching infinite size. And like we had seen back in our opening motivation, that should give me the value of pi over 2. Finally, let's take a look here at part E. In part E, we have the limit as x approaches infinity of an x squared minus a 20x plus a 10. Now, I don't know exactly what this graph looks like, but I know that it happens to be a quadratic function here. So let's just say, for the sake of argument, that it looks something like this. And now I can easily ask the question, if I follow the graph out to the right, that is, I hop on the function and I move towards the right side, which is just going to go up, 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 what value am I merging towards? Well, if the graph is just going up forever, I'm not really merging towards any value. And so I can see here I have, again, infinite. Well, maybe not again, but I have infinite here, which would mean that I'm going to end up with no horizontal asymptotes on the graph. Of course, on the last question, although I didn't write it, we knew that y equals pi over 2 was a horizontal asymptote. So hopefully you were able to try each of these individual questions, and if you didn't get all of them, that's okay. This is still part of the learning process, but you want to always try to test out, even if test out problems to see what you know, even if they're hard. They give you a sense of kind of where you're at and what you might need to work on as you move forward.